Okay, this is a video for lab 1 for the FEM portion, and we have about 3 or 4 labs for the FEM. The first one is to get the CAD and modify the idealized part or the idealized CAD. Then we do the mesh. Okay, then later on we do the assembly and get results from the sim. So today we're gonna start with the FEM in the sim. And first you need to go to web course, download this zip. Okay, unzip everything into a folder, just like this. Okay, then you need to open the assembly file. So you can go here, find your folder, open the assembly. Okay, now we're in the modeling application. Okay, so you can click start button and switch to the simulation application. Once you switch to simulation application, we need to create the FEM and the sim. So we can right click here, do a new FEM and a simulation, and it'll ask you what kind of analysis. We just keep everything default. Make sure the idealized part is checked. Okay, so take a look. We have only the assembly right now. Then if you click OK, we will have 4 files loaded: sim, FEM, the assembly, and that's the idealized part. It's a .prt file. It's still a CAD. The only difference is it's the idealized CAD for the FEM or for the simulation. So we have some explanation here for the idealized part. Basically, it's intermediate CAD between your master CAD and the simulation, so you don't mess up with the master CAD for manufacture. Then you can do all kinds of modification on the idealized part than for the simulation, like simplification, those kind of things. And we will do some modification. Then go back to this window. It's actually your sim, and it'll ask you what type of solution you're doing. Okay, so static, everything default. Say OK. Then we need to go to the idealized part first. Before that, we can take a look at the FEM. Okay, we have 6 polygons, those 6 parts from the CAD. Okay, and remember we have 6. Later on, we will have more from the idealized part. So once you get into the idealized part, you might have a warning, but just click OK. Okay, and make sure you see ideal on the top, and it's in advanced simulation. So the idealized part is, as I said, it's a CAD for the simulation without jeopardizing your master CAD. And before you do any modification on this idealized CAD, you need to do one thing that's called promote. Okay, if you don't promote, you will not be able to modify that. And so we need to promote these 3 pieces. Take a look at the slide and say OK. Nothing happened, but if you go to the part navigator, remember this is a CAD. So in the part navigator, we have 3 promoted body. Okay, and next step is to do the modification. And the idea is first we will find the mid surface for the link and the handle, these 2 pieces, and we will mesh the link and partially part of the handle in 2D mesh and part of the handle in 3D mesh. So the mid surface command is right here, mid surface. So we need to find the mid surface for these 2, and the strategy is progressive. Then once you change that, you can click this button. It'll create the faces, and you zoom in, you can see the mid surface right in the middle, and we can say OK. And you notice we have some new stuff showing up in the navigator. Right. The next step is to cut the upper jaw in half. Okay, because we're gonna mesh the upper jaw in 3D Tetra, but we will not mesh the whole thing. We just mesh a half. This way, you get a nice symmetric mesh if you reflect a half into the other side. And ideally, you should mesh all the 3D, all the mesh. If it's a symmetric CAD, you need to mesh them in half and reflect, or mesh them in half, run the simulation only for the half, that half. Okay. And somehow I forgot to do that for the lower jaw. Anyway, so we do a split body for the upper jaw here, and the tool or the cutting plane is a new plane, XY plane. So this one, ZC, is your XY, right? And apply, that'll cut this in half. And I believe the next step is cut the handle in half. We will mesh the top half using 3D mesh and mesh the lower half using the mid-surface 2D mesh. So we will be cutting this handle as well as the mid-surface of the handle. So you want to make sure you have two bodies selected. And here we have the cutting plane is right on the arc here. So we use on curve method. Okay. And I'm not gonna explain that much in the video. You can read the slides. Okay, so on curve and select the filter to single curve. Then we'll pick this arc, and where the plane will be, you can drag this point to the end of the arc. So this will be here. Then you can click OK. It'll cut both the 3D and the mid surface of the handle into two parts. As you can see here, you can change it to static wireframe to make sure you have a line in the middle that is for the mid surface. Okay, after the cutting, we'll go back to the fan, and you will have this notification saying your polygon is modified. Then we'll open the polygon tree in the simulation navigator. Now we have 13 polygons. Before we had only 6 polygons. That is because we cut something in half, generating more polygons. And also here is make sure you're in the FEM and also advanced simulation. Okay. Sometimes you're in another application, you will not see the commands or the same menu. And you should rename your polygons so you will be able to find them later on. Then the first step to mesh is we will mesh the 3D meshes, and these 4 are the unmodified or the easiest 3D mesh. So we'll use 3D Tetra mesh, Tetra 4, size 0.075, okay, which goes in here. Then 2 ways you can pick all of them at once, because they're the same size, same mesh type, and say OK. Or you can pick one and do apply, pick another one to apply. So the first method will give you only 1 collector with 4 meshes, and that is OK because they are the same material. And the second method, if you mesh them separately, you will have 4 collectors, and it's just a preference. Okay, and the next step is to mesh the half of the upper jaw. So do that again, Tetra mesh, same size. Okay, we'll pick the top one. If you pick the bottom one, you just need to reflect the bottom to the top. Okay, so that's the half of the top upper jaw, and I would like to change the color, edit display, and change to a different color so I know what's happening here. And the next step is to copy and reflect the mesh. So before that, I want to hide the polygons, hide the mesh I'm not going to reflect, leave only the top of the upper jaw here. So then we do insert an element, copy and reflect. The reason to hide all the other stuff is so we can do a box select. And my mesh setting might be different, so you might have different number of elements here. Then the symmetry plane or the reflection plane is, again, that's the XY plane, because that's the symmetry plane we determined. So XY plane, and say OK. Now, every time you do a copy and reflect, you will generate duplicated nodes on the symmetry plane, right? I have two pieces of mesh. The bottom one is reflected, and if you reflect that mesh, you reflect the nodes on this face as well. So right in the middle, you have just double the number of nodes, and they are separate. So how do we know if these two pieces are separate or a unified piece when you run simulation? So simply, if you pull these two together, apply a force on the opposite direction. If that's separate, they will separate. They will fly away, right? So how do we know? Because we did it as reflect. So we have this element edge tool. When you open this, we want to see the free edge. So we'll pick two pieces of the mesh, then click here, generate element outline. We can go to static wireframe. Now you can see the free edge are the external edge of meshes. You see the edge in the middle, that means it considers the middle is external. That means it's two pieces. So the cause is we did a reflection. How to fix that? We have this tool called duplicate nodes. Okay, remember I said on the symmetry plane you have double the nodes. So you can pick these two. You'll find the duplicated nodes that's close, that's within this tolerance, and you can merge them by clicking this button. And something happened, but we didn't know. Then you have to do this edge check again. So we go back to element edge and pick these two and do the element outline. You don't see the edge right in the middle. That is good. So this is the whole piece. Okay, when you run simulation, the solver will consider this as a single piece. And after you're done, you want to get rid of the blue line here. You can do a refresh. Okay. Now next step is to create the 2D mesh. So we'll hide the 3D mesh and find 2D mesh, the 2D polygons. So it's easy to find them because they have different symbols. Okay, I'm going back to the shaded view and 2D mesh. Okay, and we'll use C-Quad4, and they are different sizes. The bigger one has bigger size. I want to apply. Then the link or the connection bar in the slides is 0.05, smaller size, and OK, or apply then cancel. Then you have two different collectors, which is good because they have different thickness, so you want to keep them in two different collectors. And here's the way to manipulate the collectors. You can drag the mesh between collectors, okay, just like you're dragging a file in Windows. And you can create a new collector, okay, on the 2D mesh, a new collector on the 3D mesh. It'll ask you which type of the collector, then you can drag the mesh into that collector. Okay, it all depends on what type of physical property. So because these two will have different thickness, so you want to put them in separate collectors. Alright, so the next step is to create this T-shaped 2D mesh. Reason being is here the handle is transitioning from 3D to 2D, and we want to connect them. And we decided to use a mechanism called surface-to-surface gluing in the simulation. And it'll glue two surfaces of mesh together. So we need to create a face to glue to the 3D mesh. Okay, so we'll be extruding this edge two directions. Then extrude element is here. So insert, we'll be insert this T-shaped mesh using this extrude method. And we'll extrude this element edge. And here you can use a method to pick the whole edge. Otherwise you have to pick them one by one, like the one. That's 1, 2. Okay, that is one way. If you have less than 100. If you have more, you can change this to feature element edges. And you need to remember this, or you need to, well, you will use this a lot. Okay, feature element edge, it will pick element edges within certain tolerance. The tolerance can be customized inside this arrow. So now it's 30 degrees. That means if two edges are within 30 degrees, they will be selected. So these are all within 0 degrees or 1 degree. So if you click 1, it'll select the whole thing. Then the parameter here is 3 copies, positive z direction. We don't have symmetric extrude here, so you have to do it twice. Okay. And per copy is 0.0625 inch. Type C-quad 4. Let's take a look at the slides, and I'll do apply first. Then the second extrude is negative z direction. Keep other parameters the same. Now we need to pick the edge again. So feature element edges. Pick that edge. Okay, so that is the T-shaped edge to glue to the 3D mesh. Then you have those two extrusion mesh in separate collectors. Because it's actually the same piece as the handle, so I would like to move these two into the same collector. So this whole thing is for the handle. Oh, I guess that's not the right collector. I'll move to the first collector. Then that is for the 2D handle. Okay, so we don't need these two. Just delete. And you might ask, are they the same piece? Are they a single piece in the simulation? Just like your upper jaw. Okay, we did merge nodes. And here, when you extrude, you don't generate extra nodes. So the nodes on this edge is actually still the same as before. You don't have extra nodes. This piece is sharing nodes with the other pieces on this edge. So the principle is if you share a node, NX will consider this as one piece, a solid piece. So these three actually are just a continuous single piece. Okay, then next step is also the last step. We will create this C-bar for the jaws to clamp. So turn on the 3D meshes. We need to create a C-bar here, and as you can see, we created a node right in the middle of the C-bar. This is for the constraint in the simulation. Okay, we will apply a fixed constraint on this node. So when you have the results and do an animation, the two jaws will come together towards this node. It is a little bit easier for people to conceptualize the results of your simulation. Okay, so it's more like a real world. They they're binding together towards the center. All right, so to create the node in the middle, you want to use insert node between nodes. Okay, and we have a perfect node on the top, right on the symmetry plane, because that's half and half. And the bottom in the middle, sort of, seems like that's on the symmetry plane. Okay, we'll insert this one anyway. So if we do F8 here, you can see the difference. The lower jaw. Okay, we'll find the lower jaw. That's the lower jaw. The red one is the top. Upper jaw. The upper jaw is perfectly symmetric on the XY plane. There's a line here. And the lower jaw is not. We rotate off a little bit. You can see in the middle, the mesh is not really stay on the symmetry plane. That's why we did a half and half for the upper jaw. But somehow we got lucky. This node is right on XY. We can do a check. So you can do edit node and modify coordinates. Okay, actually we don't modify it, we just take a look at the coordinate. So as you can see on Z direction it's 0, so that node is on XY plane, so which is good. If you want to change, just check the box, then you can change that. So we have 3 nodes, then we'll be sharing this node top and bottom between the jaws and the C-bar. This way, the mechanism here will explain later. Okay. Even though they share a node, this bar can still move or rotate on the 3D Tetra mesh. That is the nature of your 3D Tetra. They don't have rotational degree of freedom. So even it's welded onto a 3D Tetra mesh, it will not transfer the rotational degree of freedom, meaning it can still rotate even they are connected. So anyway, we'll insert the element and create as a C-bar from the top to the middle. Then this next section is from the middle to the bottom. And you can take a look here. We will be adding the bottom element into the first element to create a single mesh. You can do a new mesh. It doesn't matter in the simulation because you share a node in the middle. So the 2 sections of the C-bar will be considered as one. And here we just use default from the middle to the bottom. Now we have one mesh, 2 elements, 3 nodes. Okay, and the next step is to define the radius of this C-bar. And you should know this by now. Just right click on bar collector, monkey wrench. Then here for the P bar 1 monkey wrench, and the 4th section is for the 1D mesh. So we get into this section manager and create a new section. This one is the rod. Your homework did a bar, right? So the dimension 1 is your radius, is 0.0625, and we'll say OK. And it's selected. We'll close this, close that. You can see the geometry. Okay. Sometimes you might not want to see a solid bar. You can change the display by right-clicking on the bar collector, edit display. And then you can change the display section into curves and apply. Now, even though you are in shaded with edges, you can still view the C-bar as a hollow or static wireframe type of style. So you can see a node in the middle. Alright, so I guess that's all for this first lab. Okay, So the next lab will be material and assemble all the meshes together. Thank you.